Hey everyone, welcome back to the channel. Quick question. If you have ever wondered how companies like Netflix, Shopify, or Stripe handle millions of web requests without exposing every single server on the internet, the answer is a reverse proxy. And today, we are going to build one for ourselves. In this video, I'm gonna show you how to set up Nginx as a reverse proxy using Docker, routing traffic between a front end container and a back end API container, just like a real production architecture. No prior Docker experience needed for this. If you can open a terminal and run a command, you are ready. By the end, you will have a fully working 3 container setup running on your machine, and you will understand exactly why reverse proxies exist and how they work under the hood. So let's get into it. Before we write a single code or single line of a code, I want to make sure you understand what we are building and why we are building. Okay, so if I share my screen, okay, if I share my screen, okay, so look at this diagram, the architecture. Okay, we have 3 Docker containers. Think of each container as a separate little computer running inside your machine. Okay, container 1 is the front end. It serves the web page you see in the browser, like HTML, CSS, and JavaScript. Container 2 is the back end. Okay, it's a Python Flask API that returns data in a JSON format. And container 3 is a Nginx, or in writing it's written as Nginx, but in pronunciation it is called Nginx. This is the reverse proxy, and this is the important one. Okay, here is the key concept. Only the Nginx container is visible to the outside world. When you type HTTP localhost in your browser, you are talking to Nginx, full stop. Okay, Nginx then looks at the URL path and decides where to send that request internally. Okay, requests to slash the home page, okay, get forwarded to the front end container. Requests to slash API, basically the API get forwarded to the back end container. If the request is like slash forward slash, it take you to the home page, means it take you to the front end container. Okay, if request is like backslash API, then the request is forwarded to the back end container. The user would never know there are 2 separate servers exist. That's a reverse proxy. Okay, compare this to a regular proxy which hides clients. A reverse proxy hides the servers. Okay, why does this exist? Because why does this matter? Because of security, scalability, and simplicity. You expose to one port to the internet, and Nginx handles everything behind the scene. Okay, so here is the project I want to show you. So we discussed the architecture. Okay, we discussed about Nginx reverse proxy. This is in this video I am showing you this Nginx reverse proxy demo, which is a production style Docker project demonstrating how Nginx acts as a reverse proxy, routing traffic between a front end container and a Flask but back end API container. Okay, we discussed the architecture. So as far as prerequisites, we need a Docker desktop installed on your machine. This is the Docker desktop, right? So I already installed on my system. Okay, and then we will run the Docker file, or we compose the Docker files or Docker containers. Okay, so this is the project structure. Let me show you the structure before we touch any code. Okay, so this is my project file, Nginx reverse proxy demo. In that I have three containers: front end, back end, and Nginx. Okay, in front end I have the index HTML file, or I can show you here, right? So I created a folder on my Visual Studio Code as I was explaining this here. So this is on the left side of the menu bar. You see the front end container has basically 4 files, right? Docker file, index HTML, script, and style. So basically index HTML is basically the web page. The style CSS, the style CSS is basically the styling for the HTML page. Script, basically a JavaScript file. This is the API call logic. Okay, this is the logic behind that API call. And then the Docker file I have, this is for how to build a container. Okay, so I have 4 files in front end. Similarly, in back end I have basically 3 files. Okay, the app py file, basically this is the Flask API routes. Okay, and then I have a requirements.txt file. These are the packages I used for this project: Flask course, and guinea corn. Okay, and then I have a Docker file. And then besides backend container, I have a Nginx container, and in Nginx I have a Nginx configuration file. Okay, this is the reverse proxy configuration. And then these are the 3 main containers, and then I have a Docker compose YML file. This wires everything together. It combine or wires these 3 containers together. Okay, these 3 folders, 1 compose file. Okay, that's the entire project. Each folder becomes 1 Docker container. The Docker compose file is basically the conductor, as I mentioned, is a conductor that starts them all together. Okay, so now I want to show you the front end section. Okay, in front end container I have that index HTML file. So this is a simple web page with the title, if you see, with the title Nginx reverse proxy, Nginx reverse proxy demo, and it has a description, right? So it's all the description here, and then it has a couple of buttons, right? I'll show you buttons. So these are the buttons, right? So these buttons call the API. The interesting part is in the script .javascript, this file. So take a look. Okay, when the user clicks a button, this fetch call fires. Notice the URL. Okay, just /API / not a full URL, basically, not a different domain, just a path. Okay, why? Because from the browser's point of view, everything is on localhost. It sent the request to the same host it loaded the page from. Nginx intercepts it and route it internally to the backend container. The browser never sees the backend, only it sees the Nginx. Okay, only Nginx does see all the browser work behind the scene. So now let's look at the Docker file. Okay, in the front end. So in Docker file I have 3 lines. Okay, this is the beauty of Docker, right? From Nginx Alpine, so this is the line number 1. Okay, starts from the official Nginx Alpine image. Alpine is basically a tiny Linux distribution. This gives us a 23 megabyte container. Okay, this gives a 23 megabyte container instead of hundreds of megabyte. Line number 2 is the copy our HTML, CSS, and JavaScript files into the folder where Nginx serves files from by default. Okay, and line number 3, expose 80, basically the document that this container listen on port 80. This is for the document that listen to port 80. Okay, this is for documentation. Docker doesn't enforce it. The real port wiring happens in Docker Compose. That's the entire front end container. Now look at the backend container. So backend is a Python Flask API. Okay, and Flask is basically a lightweight web framework which is great for building APIs quickly. So in that Python file of this application, in the backend, I have a basically 2 routes, right? The route number 1, okay, is the root, okay, slash, right? It returns a JSON response saying that the backend is running. Okay, yeah, and then the route number 2 is a health check endpoint. This is a standard in every production system. Okay, basically it checks the health of the application, right? And yeah, Flask backend, it return a JSON response, status healthy. Okay, if it is healthy, right? So health check endpoints let Kubernetes, AWS load balancers and monitoring tools know your service is alive, and if this endpoint stops responding, the platform can automatically restart your container. Always include one. Now the backend Docker file. Okay, this one has more going on, right? So we start from Python 3.11 Slim. The Slim version cut out a lot of unnecessary packages, keeping the image small in Docker. And here is a trick every Docker developer should know. We copy requirements .text first or txt file first, install dependencies, and then copy the rest of the code. Okay, yeah, copy these requirements and run dependencies, right? And then copy the code, right? Copy dot, right? So Docker builds images in layers. Each instruction is a layer. If the requirements file has not changed, Docker reuse the cached pip install layer. Your rebuild go from 60 seconds to 3 seconds. This is called layer caching, and this is one of the first optimizations you learn in Docker. The CMD starts the application with the unicorn, not Flask's built-in dev server. Flask's dev server is a single threaded, not safe for production. Unicorn is a proper server that handle multiple simultaneous requests using worker processes. And then we have Nginx, right? Where is that? Nginx, right? Configuration. So Nginx configuration file. So this file is the brain of entire setup. Okay, everything else is just plumbing work. This is where the routing logic lives. Let me walk you through the 3 key concepts in this file. Concept number 1. Okay, concept number 1 here. The upstream block, this block, the upstream block is a Nginx address book. It defines where to send traffic. Okay, notice we are using the words front end and back end. okay, not the IP addresses. Okay, this is Docker's built-in DNS at work. When all your containers are on the same Docker network, Docker automatically creates DNS entries using the container name. So front end resolves to whatever IP the front container got assigned. You never need to know the actual IP address. Okay, this is huge thing. Container IPs change every time you restart. If you hard coded an IP, your configuration would break constantly. Using service names make it robust, right? And then concept number 2 is location blocks. Okay, so yeah, location blocks here. Yeah, so location blocks define URL routing rules. Any request starting with the /API, right, /API gets sent to the backend. Everything else goes to the front end. Here is a subtle thing that trips a lot of people up, that trailing slash after back and service. With the trailing slash, a request for API health arrives at Flask as a /health. Without the trailing slash, it arrives at API health. Our Flask routes are just health and slash. So we need the trailing slash to strip the API prefix. So one character make a huge difference in behavior. And then concept number 3 is the proxy headers, right? You see the proxy header for host, for real IP, which is a remote address, and then a header for forward request, right? So when Nginx forward a request, it adds these headers so the backend knows where the request originally came from. X real IP gives you the client's actual IP address. Without this, every request would look like it came from Nginx itself, okay, which makes logging and security tools useless. And then moving on to the next file, which is a Docker Compose. So Docker Compose is how we wire all 3 containers, front end, back end, and Nginx together in one application. Instead of running 3 separate Docker run commands, we define everything in one YAML file and start it with a single command. Look at the front end service. It has a front end service, right? It has a build path, right? A container name, build path. It has a container name, and it's on app network. So no ports listed here. Which is intentional. It is not accessible from your laptop directly. So same for the backend. Okay, no ports, completely internal. Now look at the Nginx Proxy service. This one is different here. So port 80 basically on your laptop maps to port 80 inside the container, inside this container. That's the only connection from outside world to our stack. The volume mount replaces the Nginx's default configuration file with our custom one. The colon RO here at the end means read only. Okay, Nginx can read it, but not it cannot write on it. Okay, or write to it. And then depends on means Nginx waits for front end and back end to start first. You don't want a proxy trying to route traffic to containers that don't exist yet. At the bottom, the network definition. Okay, the bridge driver creates a private virtual network. All 3 containers live on it. Okay, they can talk to each other using container names. Your laptop cannot reach front end or back end directly, only through the proxy. This is a network isolation. It is fundamental to production security. Okay, now let's run the live demo. If I go to the terminal, on my VS Code. So let's run docker compose up dash dash build. So this dash dash build flag tells docker compose to rebuild all images from these 3 docker files. You only need this flag when your code changes. Okay, after the first build you can only use docker compose up. Without it, it will start much faster. Now watch the output. Okay, you will see you see the docker downloading base images if this is your first run, and then building your custom images layer by layer. Okay, for all front end, back end, and Nginx Proxy. Okay, so that that catching trick we talked about earlier, you will see it here. The pip install layer gets where I'm at. Yeah, the pip install layer gets cached after the first build. When you see worker process started, okay, worker process started. So basically I have all the 11 files up, and those 11 files are pulled and build is done, exported to my docker desktop, and all 17 basically those files are basically pulled, built, and created, front end, back end, Nginx. So looks like everything is composed right for my build. If I go to one second, it says view in docker desktop. Yeah, I wanna view in docker desktop. Okay, so I wanna type v. So let's see the docker desktop. Oh, right here. Yeah, so you see the front end, back end, and Nginx Proxy. These 3 containers are are created, right? Yeah, this is running now. This is green running, right? If I click here, so now I wanna open the browser. So let's open the browser. Okay, let me open the browser. Let me open the browser here. So if I type http localhost, see here. So this is my browser, right? Localhost and Nginx Proxy on port 80, front end, then back end, right? Now, right, so this is the basically HTML page is being served by the front end container through Nginx Proxy. Now watch this. Okay, if I click the get API button here, it says the backend is running. Flask backend service I'm using, version is 1.0. Okay, so this is basically a JSON response, okay, from the Flask backend. That request left this browser and hit Nginx on the port 80. Nginx then stripped the API prefix forward to the Flask container on port 5000. Okay, yeah, 5000. Flask returned the JSON, Nginx sent it back. All of that happened in milliseconds, have you have seen. Let's check the health endpoint too. Okay, if I click here, health, the status is healthy. Flask backend status is healthy. Okay, now let me show you the containers from the terminal. Yeah, so let me go back from the terminal. Actually, I want to show you. So where is my code here? So oh, from the container, now I'm gonna show you, right? So if I control C, if I type docker ps, oh, because I stopped it, right? Let me compose and build again. View log. Okay, so if I type docker this command, so my three containers, right, backend, frontend, and Nginx, these three containers are running, right? You see the status is up for past 10 seconds now. Look at the ports, this column. Only Nginx proxy, you see, shows 0000 80 80, right? The front end backend containers show nothing, like that. Okay, they are running but completely unreachable from outside the Docker network, exactly as designed, right? Now if I type docker network list, so there is our app network bridge. Okay, if you want to dig deeper, you can run docker network inspect on it. You will see all three containers listed as members with their internal IPs. Okay, okay, let's see, I can try another thing. Docker logs Nginx proxy, right? So every request Nginx has processed, logged in real time. So whatever we have done so far, it has been logged in real time. You can see the get requests, right? Everything I did, so it lists everything. Yeah, you see the get request to / and to API / going through. Okay, so before I wrap up, here are three issues beginners hit most often. Issue 1, you could face port 80. It could say port 80 already in use. Another app on your machine might be running usually Apache or other Docker container using the same port 80. Either you can stop that app or you can change the port number in Docker Compose YML file from 8080 to some other port like 8080 semicolon 80, and you can visit the local host http / localhost 8080 instead of just typing localhost 80. Okay, so issue number 2 could be you can get a bad request, bad gateway, 502 bad gateway on your API. So this means the Nginx can't reach the backend container. Usually the backend is still the backend is still starting up. Wait for 5 seconds, refresh. If it persists, check the backend log, and you can check the backend log actually, which I did, right? So docker logs backend, right? So this can show you the your log file for backend. So issue 3 could be, so you made some changes and changes not showing after rebuild. So you should always pass the -- build flag when your code has changed. Without using the -- Docker starts the old cached image. Okay, so now I can do this. Let me clear my screen. Docker compose down. Okay, so I removed my containers. Docker compose up dash dash build. So I build them again. So when you're done, clean everything up with the Docker compose down. So basically that stop, as you have seen, that stop and remove the containers and the network, nothing left behind on your machine. So all right, so let's recap what you have built today. So before doing that, let me type this Docker compose down. Okay, and I can check my Docker file. See, it's gone. All three containers are gone. It's not showing up, right? So let's recap what we have built today. So we have a 3 container architecture where Nginx act as a reverse proxy, routing all the traffic through a single port while keeping your front end and back end completely isolated from the outside world. Okay, you learned how Docker's built-in DNS lets containers find each other by name instead of using ports. You learned how Nginx upstream blocks and location blocks control routing. You learn how layer caching makes Docker build faster, and you learn why we use a Nginx instead of a Flask's dev server. This is a real production pattern, not a toy example. Companies run architectures exactly like this, usually with more services behind the proxy, but the core concept is same. Okay, from here you can extend this further. You can add SSL termination with the let's encrypt. You can add a rate limiting. You can swap the front end for a React or next JavaScript application. You can add a database container, or you can deploy the whole thing to the cloud platform like Amazon Web Services, ECS, or VPS, right? If this helped you, hit the like button. It genuinely helped the channel reach out more people. Okay, subscribe if you want more DevOps and cloud content like this. Drop a comment below. What are you going to build on top of this setup? I read every comment. Okay, this is my new channel. I try to upload content related to DevOps, related to AI, related to machine learning. I try to do it once a week or 2 videos a week, something like that. So thank you so much. I'll see you in the next one. Okay, thank you.